Good afternoon, everyone. Are we good with the slides? Yes, no. Oh, a little spoiler. So I'm Raphaël. Thank you very much, Maya, for the intro. Today, I want to share with you how we used a product-first approach to building our first machine learning component at GetAround. And it's not only me, I'm obviously representing the team here only, and the team I know is in the room as well, so a little round of applause as well for them. They are the one who actually did the job. First, a little bit about GetAround, starting with the problem. So transportation is the #1 cause of greenhouse gas emission in the world, which leads, as you know, to climate change. And personal cars account for more than half of that. Then you have air pollution causing 4.2 million deaths, premature deaths every year. And personal cars also waste a preposterous amount of land in our city. In a city like Paris, by comparison, it is the 7 most central boroughs that you could cover fully with cars that are only used 10% of the time. And so car sharing solves this, and this is why our mission is to empower people to car share everywhere. So how do we do that? By providing our customers access to safe, convenient, and affordable cars around them. And so what we are is the #1 connected car sharing marketplace. Connected because you just book a car on your phone, unlock it with the app, and off you go. And marketplace because just like Airbnb, we do not own the supply, we do not own the cars, and instead we have a much more scalable model relying on the network of distributed owners. Okay, back to our topic, machine learning. Just to make it clear, here we talk about in-house, custom-tailored models, and not the kind of ChatGPT-like LLMs integration and so on. Don't get me wrong, these are super interesting as well product-wise, but they deserve a talk of their own, and I think there's another talk about that at the moment, so I strongly encourage you to catch up the video as well. A bit of context. So the application we are talking about today is smart pricing. Smart pricing is a way for the owners to have their prices set automatically for them and optimized. So they will earn more money, and they will also save time because they don't have to go back again and again to set their prices and to update them. So let me ask a quick question first. How many of you in the room think they are data science literate enough so that they can follow the technicality of the presentation? Raise their hands. Yeah, technical crowd, maybe a third or something. Well, that's great, because here's the thing, it does not matter. It does not matter, because if you want your launch to be a success, it's not a technical problem, it is a design challenge. Okay, it's also a technical problem. But even there, we'll see it's not all about the algorithmic power of it. And so here's a way, hopefully simple, to look at it. Say you work a lot on your algorithms, you're going to improve prices by 5%, 10% maybe if you're good, and do better by 10% compared to what an owner would do manually. That's meaningful. But the thing is that because it's a new launch, it's worth nothing if nobody uses it, and if no owners opt in for it. So this is why you want to focus as well on adoption. And that's the figure on the right. And so as you can see, you probably have 5 times more leverage at the beginning on the impact for your success metric by working on adoption than on the algorithm. So later on, when you start having 50, 70, maybe 100% of adoption for your feature, then of course, improving your algorithms will matter a lot. And that should show as well in your teams and organization. So for instance, at GetAround, the Marketplace Dynamics squad, which is responsible for smart pricing, is one of our most technical squads. And yet, it's not only about data scientists and so on. We also want it staffed with some product design resource. Speaking of product design, so it's a design challenge first. Product design at Getaround regroups UX writing, UX design, and user research. And so every feature we build them with those competencies and skills, and machine learning features are no stranger to that. So we started with user research. What we did is that we came up with some initial Figma designs. And the goal was to improve them and adjust them for better conversion. We did the interviews remotely with Google Meet. And in that case, we recruited the interviewees on our user base because it made more sense to have owners that already know and use our platform. And for those who haven't done qualitative user research in the past, you'd be surprised to see how little and how few interviews you need to start gaining some very, very valid insight. So usually something between 5 and 10 is the magic number. So what did we learn from the interviews? Well, it is all about trust. Let's have a look at some of the quotes that came from the interviews and the vocabulary that has been used. I hope that the algorithm does its job. I would have tried smart pricing just to see. There's a button to deactivate anytime, and that's reassuring. So basically, even if the owners, if your users are going to understand what the application does, they will not trust the machine. They will not trust that it will be able to do better than them, and that it will understand their specific use cases. And so for that, we try to reinforce trust by adding a preview of all the prices that would be set for their cars before they actually validate the opt-in. And this lack of trust is even more true when the application is about money. It's going to be different if it's, I don't know, like content recommendation, for instance, but for money, it's even more critical. And so we had to go the extra mile in terms of adding a screen with extensive copy and reassurance on this. And so they had a real fear of losing control, basically. And so we also decided to leave them a bit of control in that feature. So yes, the smart pricing is fully automated, but they can do two things still, or actually three. They could set a minimum price. They could override some individual prices for a given date. And of course, they could opt out anytime. And since you're going to have to reassure your users, make sure you do one thing. Write down the exact words that they are using during the interviews. Because these are the words they know, use, and understand. So you want to make sure that you speak their language. In our case, here's one small example. So there's this feature where you have a floor price that the owner can set, under which the smart pricing will never go. And so based on the interviews and the language that was used, we called it minimum price and not something else. And so here we are. We rearranged our different screens and our flow, and we ended up with a nicely converting flow, which was starting to propose and engage and present the benefits of the feature, so what it is. Then explain a little bit how the algorithm works, right? You want to make them understand that the algorithm thinks like a smart owner would do as well. Basically, what kind of data is it using to infer a price? Then introduce the stay in control features that I just talked about. So minimum price, be able to override a price for a given date in the future, and then opt out. And by then, it could be still a bit daunting to take the leap and opt in. So again, we reassured them with the presentation of all the prices that have been generated for their car in particular. And once you've done this, you've probably made all the work. And so we just took the opportunity to make it smart and cool with a little animation at the end. Okay, so now we have a nicely converting flow. But if you remember the metrics that we were looking at, it's adoption and not so much conversion. And adoption is the product of conversion and acquisition. So I just wanted to remind quickly that you need to throw a little bit of product marketing as well. Really basic stuff that we did. So in-product announcement, in-product banners, emailing, push notification, blog post, you name it. Okay. Now back to the technical part of it for the 30% of the crowd then. Well, not quite again. Because even the technical part, the data science part of it, is going to be half automated and half human. And to present that, we came up with a framework that I want to introduce. We called the 4 O's. So organization, which is manual, Oracle, automated, observation, manual again, and optimization, automated. Starting with organization. So any machine learning project will be, no surprise, very data intensive, right? So that means that you want to organize a lot and clean your data for your model to be efficient. In our case, for instance, we needed to save in our databases all the prices and dates for which a car was booked, but also all the prices and dates for which a car wasn't booked. So that's obviously a lot of data. And so you want to make sure that all this data is clean to be consumed by your algorithm, but also because we have a lot of manual stuff, by your teams as well, who are digging it. Then in terms of organization, you want to organize a good routine. We saved tremendous amount of time by having a clear routine that we followed each week. And here it goes. On Monday, we would run the price computation. So the algorithm would run and output all the prices needed for all the cars. On Tuesday, we would analyze this output and see what looked weird, etc. On Wednesday, we would do all the adjustments, manual adjustments on top of this output. And then on Thursday, we would run the actual import in production in our database. Second O, Oracle. So Oracle is basically the way we use to describe and to predict what's going to happen in the future. So how do you price something in a free market? You just look at supply versus demand, the balance between those two. Supply versus demand, in our case, it's more or less the searches, so demand, people interested in renting a car, versus supply, the number of cars that are actually available. What we found out is that for the supply side cars, just looking at the number of cars that we had, for a given date, is a very good proxy. Maybe if you're in a fast-growing market, you can put a multiplier depending on how far in the future you're looking at. But otherwise, it's fairly simple. So we'll focus more on the searches part. First thing you want to do, looking at your searches, what we did, is to filter out the noise. So as part of this process, you will be looking at competition as well. We'll see that later on. And so you will be scrapping them. But that means as well that there's a lot of people scrapping your site and a lot of bots. So this is the orange line, basically, that you want to filter out, right? And you want to end up with only real searches from real people. There are several ways to do that, but usually, if you start by removing all the headless requests to your site, it's already a good start. And sometimes, by the way, if you look at the graph, the non-filtered version could be 3 times as high as what you actually want to look at. Second thing we looked at is actual bookings, because this is an even stronger signal than searches, because searches are kind of an intent, But bookings is an actual booking place, so it's very strong as a signal. You have lower volumes, but it's very strong. So we baked that in as well. And we split that in two. We looked at, for the next 3 weeks, we looked at the booking actually placed already on our platform. And for anything beyond that, because it's hard to start to be precise, we used a model that is provided by Facebook, which is called Prophet. Okay, and here's the results. One is for London and the other is for Lyon. Obviously, we took some results that worked pretty well, but we were starting to have like really good results as a first approach. Third, observation. So what we did so far is that we were looking at everything that was happening on our platform. But the real market is not everything that happens on GetAround. The real market is you plus your competitors, or even extended competitors. You know, in our case, it's maybe the Hertz and so on, some other car-sharing player, but it's also maybe Train, etc. And so what we did is that we started to have a brick that was being able to look at what the competition looked like in terms of, you know, do they have still a lot of supply or not? This is where, you know, our scraping comes in. What are their prices, and so on. I'll give you an example. Maybe we still have a lot of supply available on GetAround. So the algorithm should say, hey, push the prices down. But what if, for, you know, an exogenous reason, the competition has less supply? That's actually what happens after COVID, where all the Hertz, Enterprise, Europcar, etc., they ran out of supply. While the prices of the market went super up, and so we actually raised the prices as well. And then the second thing in terms of observation, which is more centered on ourselves this time, is looking at the trends. Sometimes your model is not going to catch something that is not like very cyclic and so on. Let's say you're in Lyon again, and this year at this date, but it's the first time there's a big event that brings a lot of people. Well, this is going to be hard to catch, but if you look at your data like a few weeks in advance, you're going to start seeing some spikes, and there you want to be able to, you know, add some bonus to the prices as well. And all of this was very, very manual at the beginning. And last O, optimization. And optimization is optimization of two things. The first thing is revenue, and the second thing is time. So any machine learning project will ask one question. What do you want to optimize for? You know, you could say, I want to optimize for as many bookings as possible. I want to optimize for a booking being at the maximum price as possible, etc. In our case, we wanted to optimize for revenue, maximum revenue over time, so which is a product of booking probability and price. And so what we've looked at up to now is basically the masses, you know? We're looking at all the searches on the platform, etc. But the prices we're setting, they are custom to every single car on the platform. And all these cars, they have very different characteristics. So our model, we optimized it by putting all the market context, so which we talked about earlier, so everything about competition, the supply, and the demand overall. And also the specific characteristic of one car. Is it a car with the Connect device? Is it new on the platform? Does it have a lot of reviews, good reviews or not? Is it close to a train station, etc., etc.? And last part is optimization of your time. So yes, we started with a lot of manual operation. It also helps you learn a lot more about, you know, how your algorithm is working, etc. But over time, it's taking obviously a lot of time to the team, and so you want to be able to optimize this and automate it. So all the prices import at the beginning, they were very manual, so a lot of command lines, etc. And so we streamlined it. sorry. The prices computation, sorry, they were done very manually at the beginning, and we automated them. The analysis, it's still a very manual component. We have some pricing managers that are looking at prices all the time. The adjustments, this we manage to optimize and to automate them. So for instance, everything I mentioned around the trends, is there a spike coming up? This can be detected automatically, and then the boosts on the price, now they are generated automatically by the algorithm. And then same thing about the import, importing the prices. When we look back at our 4-day routine, importing the prices, same thing. It was something very manual at the beginning, and we automated this. Okay, so to end with, just a little recap. If you want to boost adoption, invest early in qualitative research and product marketing. So again, it's first, if it is a new component, it is first a design problem. Double down on UX writing to make your algorithm tangible. And a good routine, back to the technical part, is as important as a precise model. You will save a lot of time. And then we threw in an extra one. So if you're starting with machine learning, start narrow, but vertically integrated. And I'll try to illustrate that with two things. One is a comparison, or a metaphor, and the second one is an example. So let's say you want to build a big house. You have a certain amount of resource or time to do so. What do you want to do? Do you want to build, first, a small house but fully furnished and very comfortable? Or do you want to, and that you can extend, room after room? Or do you want to first, build some big walls, etc., but you have no light, no electricity, nothing at all, and you will have to live with that for a few months? Well, what we're saying is that usually in product development, you're going to do kind of the least effort to get the 80% of your user base. In this case, because you have to nail that kind of routine and all this stack of things that you need to do in data science, we recommend that you start very narrow in terms of scope, so what you see on the left, but very integrated, so all the things that we recommended. In our case, we launched it in a very limited region, so only one country, even only one city, and doing it in cities where it's dense and not the countryside, because all the parameters will be very, very different. And maybe not even on all owners, for instance. So very limited scope. And just to give you another example, if that speaks more to you, I'm taking the example of self-driving cars. If you look at Waymo, if you know them, so they actually launched publicly in just one city over the US. They are not trying to fix self-driving in all of the US all at once. They are trying to do it fully, even if you have maybe to map all the city with LiDARs, etc., but in a very limited geographic area, even to limited beta users. But they did that with a stack of tools that was super, super extensive. So mapping the area, analyzing all their trips that they were doing with the safety drivers first, and then without safety drivers, and even building a completely virtual world to be able to simulate their trips in that city. Thank you very much. We do not have the speakers debate afterward, but I will be in the room, so feel free to come to hit me and the team to discuss more in details if you have questions over a beer, maybe. Thank you.